What I got, you can't buy. It resides between my eyes. Walked through the fire, came out better on the other side. See, life's like a beach if you find the sand. And right now, I'm feeling like 100 grand.
You are listening to Inspired Insider with your host, Dr. Jeremy Wise.
Dr. Jeremy Weiss here, founder of InspiredInsider.com, where I talk with inspirational entrepreneurs and leaders. Today is no different. I have Craig Dunham of Voltron Data. You can check him out at voltrondata.com. And Craig, before I formally introduce you, I always like to point out other episodes of the podcast people should check out. Since this is part of the SaaS series, some other interesting episodes are we had one of the founders of Zapier on, which was a really cool episode and kind of seeing their trajectory. We had one of the founders of Mailshake on, the cold email platform. And they said we kind of talked about how they grew to 70,000 users. So that was interesting as well. And Pipedrive was another one. At the time, I think they were 10,000 customers, and I think now they're over 100,000. And he talked about the journey of, brain tumor moving from Estonia to the US and just much more. So it's kind of a crazy journey for him. And this episode is brought to you by Rise 25. At Rise 25, we help businesses give to and connect to their dream relationships and partnerships. We do that in two ways. One, we're an easy button for a company to launch and run a podcast. So we do the strategy, accountability, and the full execution and production. Number two, we're an easy button for companies gifting. So we make gifting, staying top of mind, your clients, partners, prospects easy. You hand us your address list and we do everything else. So Craig, we call ourselves kind of the magic elves that run in the background to make it stress-free as possible for a company to build better relationships and, most importantly, focus on running their business. And for me, over the past decade, I have found no better way than to profile the people I admire and share with the world what they're working on the podcast and sending them sweet treats in the mail. So you can check out everything at rise25.com or email us at support@rise25.com. I am super excited to introduce Craig Dunham, a CEO at Voltron Data. He leads the global strategy and execution. He's really played a pivotal role in scaling multiple B2B SaaS companies, including Seismic and Lumar, which we'll get into. And Craig has driven significant revenue growth, led M&A integrations, expanded businesses across multiple regions and industries. He's got really a wide breadth of experience and knowledge. He holds an MBA from Kellogg School of Management, Northwestern, serves on the board of directors for the Humane League and Link Unlimited. So Craig, thanks for joining me.
Jeremy, thanks so much for having me.
Pretty cool pedigree.
Thank you. Thank you. I try to keep myself busy and doing things that are meaningful and important. And so, and I loved having conversations like this, by the way. And so thank you so much for bringing me on.
Definitely. Start off and just talk about Voltron Data and what you do. And for people listening, there is a video component. So I'm going to pull up their website as we're talking. So tell people about Voltron Data.
Yeah, so I often get asked what is and who is Voltron Data, and the shortest way I can explain it is we help enterprises accelerate computing with a really fast SQL engine. And we have this really simple mission, which is how is it that we can drive the cost of data processing or data analytics as close to zero as possible? And that's it. And so we do that by thinking about the problem in a really different way. A lot of existing technologies today that do data processing, they're leveraging CPU technology, which has been around for many, many years. And we've built a GPU accelerated engine from the ground up, which takes advantage of all the various accelerators that can happen with the GPU chip versus a CPU. And there's accelerated storage and networking and memory, and all these things matter a whole lot today, especially as we think about the world of AI and how that's evolving and how computing needs to keep up to meet the needs of these AI applications.
Yeah, I could see, there's so much more computing now with AI, and also, especially because, just the common people are using it now. So I'm sure like your solution. So I would love to talk about some use cases so people can understand how does it work, right? Accelerated computing, what does that mean? How does it work? I don't know if you want to start with maybe a large retailer and how they're using Voltron Data.
Yeah, and what I'll do is I'll give sort of a baseline overview, and then I'll tell a specific story there. But we're at this really interesting inflection point in computing today. And, this idea of like acceleration or things going faster than they had historically is becoming the standard. And so over the last couple of years, you saw this evolution that was all about how do I optimize my LLM or my large language model, and OpenAI, ChatGPT, the most famous of those. And that was the beginning of this evolution. And now what we're seeing happening is there's this shift towards agentic workflows, right? Where there's this optimization that has to happen across a much broader swath of data as you start thinking about how do I deploy these agents, and these agents are doing and completing specific tasks or answering questions, et cetera. And so in order to make those agents as effective as possible, you need to really think about acceleration across all of your data ecosystem in terms of how you store data, how you move data from one place to the other, how you run computational sort of analytics on that data. And without that acceleration entirely across the stack, it becomes really difficult to have all the AI models or agents or whatever it happens to be as effective as possible. And so, one of the use cases that we often will talk about, and it is that with a large retailer who was looking to do some inventory, let's call it inventory optimization. And, it's one of the larger retailers in the world, and they're trying to really predict what perishable goods would sell in all of their stores across the country on the next day. And the reason they're trying to do this is that they want to make sure that they know what goods to ship from the distribution centers to the actual stores to make sure that everyone who wants to buy cabbage or carrots or whatever it happens to be, that they're able to do so, that there are enough on the shelves. And so they have a bunch of raw data, which is all the transactional history of the sales that have been happening across these stores over a time horizon. And they would go do some sort of data processing overnight to be able to get things ready to feed into an AI model, which is how they would then use to predict things. And
Like if they say, okay, across all of our stores, we sell, or maybe this particular store sells like 500 bananas a month, because I've gone to like Target and they were out of bananas. I'm like, how is this possible? Because they probably didn't use you and connect it to the data points. You know,
something like that.
we sell like 500 of these a month. I think we've
Yeah.
ordered 300. We need to order 200 so that we have a supply in place, that kind of thing.
That's right. That's right. And so in this scenario, they had a whole bunch of servers that are running these analytics, and it would take them 8 hours to run the full process from end to end. And so you can imagine, if something happens during that 8 hour time frame and the query fails or something like that, then all of a sudden they're not meeting this SLA, this service level agreement, to be able to get the data to be able to predict what's going to happen in the next day. And so it just didn't leave any room for error, any room for de-risking. And, leveraging our technology, suddenly they're able to take this query job that would take 8 hours to run, and they shrunk it down to about 30 minutes. And so now you can imagine what happens is, well, if something happens to fail, they can run it multiple times. But more importantly, they can start to optimize the model now to get even better results, because they can run it multiple times and see what's working, what's not working, and apply some learnings. And so there's just a tremendous amount of value that can happen by doing things faster and cheaper. And, we always say faster, cheaper, more energy efficient. Those tend to be our sort of themes that we run on and we try to help our customers with. But, we're talking tens of millions of dollars in savings as a result of being able to predict this more accurately.
Yeah, that's what I was going to actually piggyback on, which is like if that's going from 8 hours to 30 minutes, then there's a huge time, but it's also an energy savings, like running these machines. Obviously, there's a speed to it. What have you seen the kind of advantages of cutting that down? I mean, the process in general.
Yeah. So, the base of our technology, and I talked about a GPU versus a CPU just a moment ago as I gave the intro. But GPUs by nature do use more power, and they are more expensive on a one-to-one basis. But what we do at Voltron Data is we are able to optimize the GPU so efficiently that you could, in a sense, in an ideal setup, of course, you could reduce 100 CPU servers to one GPU servers. And so again, while the GPU is more expensive and uses more energy, the ratio of savings from 100 to 1 is meaningful, right? It's not that much more energy that's used by a GPU versus a CPU. And so we're really about shrinking, the land, shrinking the energy, shrinking the amount of hardware that is required, and think about all the associated costs that come along with that.
For people who don't know GPU, what that is or what that means, can you explain briefly?
It's graphical processing unit. Historically, they'd been used for in the world of gaming back in the day. And the idea that we use GPU, and they were, and at its most fundamental level, think of a CPU as a single lane highway, right? You got one lane and everything is funneling through one single lane. Think of the GPU as like a 5, 6 lane highway. So there's this like parallel processing nature that can come with a GPU. But originally, this was used for gaming, and NVIDIA sort of made its name in and around sort of this idea of GPU for games and other companies as well. And the idea that you could use GPUs for AI then became the next sort of big major application. And for us, we said, well, actually, if you're running all of these models and LLMs leveraging GPUs, the data and analytics component further downstream, which feeds the data in to make those models more efficient, that's all being run on antiquated technology called CPUs, right? The single lane highway. So imagine if you have a single
Yeah.
lane
Would you
highway.
rather be driving on a single lane or five lane type of thing?
Exactly right. And so think about the bottlenecks that causes. You can't feed your models fast enough because you got this single lane highway suddenly feeding out to the 6 lane highway, right? And so we want to make that all more efficient.
Talk about this, and you mentioned NVIDIA here. I know your company did a post on this right here. NVIDIA Spark Rapid hits the wall. Can you talk about some of the concepts in this?
Yeah, I mean, it's a really similar idea to what I just described. And so, the thing that has happened is, we're not the first ones that have said, hey, look, it, you know, GPUs can be more efficient than CPUs for, a number of different tasks. But what is happening in the industry is that people are retrofitting their technologies to now be able to run leveraging GPUs, whereas we have built ours from the ground up. And so imagine you have an application or a technology that has existed for 5, 6, 7 years, and you're going to say, hey, I'm going to retrofit this now because I know that I can use GPUs really well and it's going to make it better. Sure, you're going to get some uplift, but we have built ours from the ground up very purposefully to take advantage of every bit of sort of compute efficiency that you can get with a GPU versus a CPU. And so it's ground up, fully, we call it accelerator native. And so that's really fast storage and really fast memory and really fast networking, sort of how data moves back and forth. And so we're all about like, how do we fully optimize every bit of computing power that exists inside of a computer or a server or whatever it happens to be. And with this Spark Rapids example that we gave here, it's NVIDIA's own technology, and they are retrofitting this to run better on a GPU, whereas ours is just the GPU native from the beginning.
In the example of the large retailer, right? So can the Voltron data basically plug into any system? So like they go in, what is are you contacting them? Are they contacting you? I mean, like, what issue are they coming to you with? It's just that processing time, or is there other things that they're coming to you and go, hey, I heard you could solve this processing time issue?
Yeah. So I mean, it's a combination of both. And so there are times, obviously, we have, a hypothesis and enough data that we feel really confident on who and what is our ideal customer and what that person looks like and the types of problems they have. And, those problems typically start to center around, hey, I've got, a large, massive, call it petabyte scale set of data, and the cost and speed and complexity of managing that data is just really high and only getting higher every day as you think about the amount of data that's being generated. I mean, everything we do from our phones to our cars to our, technology at home, everything is kicking off log data or telemetry data, et cetera. And so you can imagine the amount of it is just continues to grow. And then we think about our customers in a sense of having these problems where it's, okay, I've got to do something with that data, which typically means I need more hardware or servers to run the data. I need more land to then put those servers on. I need more energy to then power those servers, right? And so there's the problem of how do I manage these massive data centers? And then what's happening as a result is they're building out these systems. And like the example I gave with the retailer, there are these SLAs, which says, well, I've got to get this data processing workload, this join this data, aggregate this data, run mathematical computations on this data. I've got to get it done within a certain window of time, but my infrastructure can't keep up with that SLA. And so then they start down sampling data, which means, well, actually, instead of running the analytics on the full set, I'm only going to run it on a portion of the data. And then I will maybe use that and extrapolate and get to some
Right.
outcome. But
Because it's
there's risk in that.
too much time consuming. It's
Too
too
much.
much money to build more
That's right.
centers. And it's like, who cares about the bananas? We sell more electronics. Let's just do it in the electronics section of Target and forget about the bananas. Like, who cares if we sell like a 79-cent bunch of bananas?
Something like that.
But it's a
Yeah,
bad
that's right.
customer experience in the end. Who's like person, like who's the position of these companies that are thinking about this, that are worrying about this, that are coming to you for this?
Yeah. So historically for us, it's been, data scientists, data engineers, data platform leaders. So a more technical leader. But what's interesting, Jeremy, actually now is we've been testing some messaging recently, and we're getting a lot more uptick from CFOs or folks in the finance department because now they're starting to look at, costs ballooning out of control
I thought you were going
on
to say CTO
hardware.
for some reason on this, but
And those technical leaders do tend to bubble up to the CTO. But at this point, most of the buying decisions have been made at sort of like an executive VP or VP level. But sometimes they, depending on the company, they'll bubble up to the CTO. But the CFO has been caring a whole lot about this because think about the cost associated or capital expenditure that's being doled out by all these companies to try to support the needs of the business, and they're all looking for ways to reduce the cost associated with running their analytics.
I'm curious, Greg, what does onboarding look like? It seems like so technical. Like this large retailer has so many moving pieces. They're using, who knows, lots of data points, inventory software. What's the onboarding look like?
Yeah.
Do you have like a team of like developers that go in and meet with their team of developers and like integrate Voltron into the system? I mean, it's probably way over my pay grade to understand this, but I'm just curious at a high level, what does that integration look like to go in there? Because there's a lot of moving pieces here.
Yeah, you and me both, Jeremy. So I should say I am, while I run a deeply technical company, I am not a deeply technical leader. I am like my background, my history, I'm a go-to-market guy. So sales, marketing, customer success, like how do we take a story, tell a story, find repeatability? Like that's where I really specialize. But to get to your question, I like we are, and without nerding out too much, but we run and we can integrate and implement really easily to anything that has like Kubernetes, which is like a simple and easy standard that your more technical listeners will certainly understand. But we built our technology where the core IP, this core sort of SQL query engine that does the processing, is closed source, and so it's protected. We don't sort of give out the code or anything to that. But everything around that engine is open sourced. And the reason we architected it in that way is to make it really easy for people to onboard and integrate it into their existing systems. And so we don't go to a customer and say, actually, you need to rip out your entire data stack and replace everything with all new infrastructure. It's actually no. If you leverage, and one of those open source technologies is called Apache Arrow. If you leverage Arrow anywhere already in your infrastructure, it's really easy for Voltron Data to just connect our query engine in through Arrow, and it just really graciously just integrates with existing systems. And we have a concept, and we talk a lot about this, which is, not every data processing workload makes sense for Voltron Data. And that example of that large retailer, that did make sense, but there are some smaller workloads which may make sense to run on some other query engine, and we're completely okay with that. We're just saying, hey, it's really easy to integrate our stuff, leveraging these open source technologies, use us when you need us, and then point your data processing somewhere else when it makes sense to do that thing somewhere else. And over time, we're going to start to help our customers make that decision for them. We'll be able to define the characteristics, the size, the types of mathematical computations that are being done, and say, actually, you should use this other technology for this one. You should use us for that one, and help our customers with that.
Yeah, so you'll have to go in and kind of implement the code inside so that and then connect it to whatever data points they have. It's kind I
But they
guess
can do it on their
yeah.
own, though. It's actually
Oh,
pretty
they can.
self-serve. It's like, yeah, we
Okay.
give them a package, they install it, and sure, we'll white glove it to the extent necessary if they have questions, but we've
Yeah.
got documentation. We try to make it as easy as possible.
Yeah, I guess I you could tell me if this analogy is right or not, but I kind of visualize similar to like a Zapier helps connect apps, but you're like helping connect things, but then also streamlining the efficiency and decreasing the time as well. Like if you go on Zapier, it's obviously like pretty self-serve. You go and you just can connect a bunch of stuff. Yours is kind of, I mean, obviously this is enterprise level stuff, but it's helping connect it, but also just increase the efficiency and everything like that on top
That's
of
right.
connecting things. Is
Yeah,
that accurate?
that's pretty accurate. And there's a tuning and optimization process. And so, you plug it in and yes, you'll see some uptick in efficiency, but imagine a series of knobs and dials that you could turn up or down to really find the right configuration that works based on the needs that you have. And we do work with our clients to make sure we optimize their specific workloads for all of the compute capacity that we have inside of their specific system.
Talk about pricing and how do you come to pricing? I know every client's going to be different. I'm not talking like the specific amount of pricing, but like, obviously there's data being used. How do you decide to price this type of model for people?
Yeah, we use a common model in this space. It's priced per terabyte scanned, and so we basically look at the amount of data that's scanned, and we don't sort of and we sort of t-shirt size it, on an annual basis, and so call it small, medium, or large, and there's per terabyte, estimates on the number of terabytes they'll use in a given time frame. And then, if they exceed that in a given year, we're not going to come back and charge more, but we'll look and say, okay, did we pick the right t-shirt size for 2025? And maybe for 2026, we'll look at if that makes sense to continue with that size or to go up or down depending on their usage.
Is that because, from predictability from their end? Right. So they're
Uh,
not they're not paying like a monthly because I could see it be like, okay, you
no,
process this amount a month. This is the charge. It sounds like you're kind of guesstimating on the year.
we're guesstimating for it, but they typically know. Again, what we're doing, the amount of data that's being processed is not like a new thing. They have been processing
Yeah.
data for many, many years. And so they'll have a really good idea of the amount of data they need to
Mhm.
process. And you can imagine this does grow annually. And so there are ways to do
Totally.
some rough estimations of that.
I mean, that's what I was thinking is like, because they may be doing, like you said, well, this is taking too long. We're only doing this subset of data, but they have like 10 other sets that they're not doing. So I would think maybe it's hard to predict that sometimes because they have limited what they're actually processing because of that.
You are right. That's a really good point. That's part of our value prop actually, which is like the art of the possible. Like imagine if like there are all these analytics you're not even doing today because your brain couldn't fathom doing them because the technology you have can't do it. And now all of a sudden we open up and unlock this art of the possible. But for a given first year, that's great. Like I don't have a single problem with if we charge someone for a small t-shirt size and in that first year they use a large, if they're getting a ton of value and they're using it and they're talking about it,
Yeah, that's a
amazing.
good problem to have.
Great. That's a great problem to have. We'll figure it out the next year or the year after. But I'm okay with that. We want to encourage our customers to use it. And that's why we don't sort of do this every month. We change the price. It just gets too complicated for them. We don't want to give them any reason to not use it. It's we agree to a price. You got it for the year. Go nuts.
Yeah, no, it's nice. I like that. I want to hear about the evolution of the client, right? You're a go-to-market person. I'm curious how the ideal client has changed through Voltron data. I don't know if you want to start with now what's ideal and then go back to who are some of the client customers coming to you before that maybe aren't a fit now.
Yeah. So I mean, we have our ideal customer tends to be uh, larger enterprises or government organizations that have just large quantities of data. And so you think about us being a large scale query engine. And, if anyone in the audience, again, is more technical, we're talking, 10 terabyte sort of queries or 10 terabyte data processing workloads or greater. And we have scaled and run benchmarks up to 100 and are confident
Mhm.
we can go even higher.
And that's
And so
that's like a per month thing or
that
how?
that
Yeah.
That's a per scan, not even a per
Oh,
month.
Bruskin,
So
yeah. So just to
per
give people an
workload.
idea,
Yeah.
I mean, if you aren't technical, which I'm maybe like on the end of not as technical, but I think I have 3 terabytes of data on my Google account, which I haven't used in 10 years. So like, and you're talking, this is maybe scanning on a daily basis type of
Yes,
thing.
that's right, and bigger than that. And so, here the example I'll use. So we have a large global bank that is currently right now running a proof of concept with us, and they're looking at trade surveillance data, and so they want to know like the bid, the offer, the ask, prices for every ticker on every stock exchange in the world. And they're looking for anomalous behavior in this trading activity. And so imagine they're only doing it, and this is not the exact example, but imagine they're only doing it today for the New York Stock Exchange because they don't have the infrastructure that can do it for the New York Stock Exchange, the NASDAQ, and think of all the European and Asian exchanges, et cetera, et cetera. And so imagine the billions and billions. You think of an Excel spreadsheet with columns and rows, but literally billions or tens of billions of columns and rows of data that you need to sort of think about and like make sense of and aggregate and join and run analytics on to derive some insights or to look for, in this example, some anomalous behavior of somebody doing something they shouldn't do, quite bluntly. And so we help with problems like that. And so our hypothesis is, those larger customers are the ones that typically have data volumes of that size. But the problem of the largest bank today is going to be the problem of the mid bank a year from now, 18 months from now, 2 years from now, as the volume of data and the complexity of data continues to evolve.
Yeah, I mean, they're doing this anyways. Yours just maybe makes it more efficient, faster, cheaper. Because if you think of, you know, I've gotten alerts, if we've any of us have got alerts from our credit card being like, okay, Jeremy, you made this purchase in California at this store. Well, we already have all these data points. That's an anomaly on your account. We're going to immediately shut it down, right? And they're probably using all these data points to make those snap decisions and shutting my card off so they don't charge more stuff on my account.
Yeah, that is exactly right. And so we tend to see, the use cases fall into sort of four buckets, and it's, hey, I need to pre-process and prepare data to go into some LLM or machine learning algorithm. It's I want to take a bunch of transactional log data and use it to make recommendations. So think recommendation engines, like i.e., I'm customer facing, and these are the kinds of things that they might like as a result. We see it a lot with like market forecasting, sort of predictive analytics sort of data. Maybe if you're an automotive company, you want to look at, if you run autonomous vehicles, for example, and every single behavior that the consumer does, the driver does, from the nav system to how they brake and when all these things are creating logs. And so you want to be able to sort of predict when maintenance may be coming up, or how much of this like infotainment center they're using, and how do I make that experience better. I mean, there are all these like infinite number of use cases that we can solve for, but it all really boils down to, is it a ton of data, and do you need to really quickly analyze a ton of data, and is there risk to you not analyzing the full set of data possible to you?
So, at a general level, I'm curious, maybe you can speak to some weird use cases, and non-weird use cases in general. So, banks, obviously, right? Large government agencies. You mentioned large retailers. I could see large manufacturers. What are some other use cases? Have been any strange use cases that have come to you that you didn't expect?
Interesting question. I don't know, that's strange. I mean, they tend to fall into those same buckets, and some of the things you might imagine. Now, maybe an obvious statement. We don't always know the ways in which some of our federal customers, like what they're doing. That's just highly confidential. And
Yeah.
even with some of our more regulated customers, like the larger banks that we have, they're really confidential about how and what they're doing with the data, probably for competitive protection in
I
some
mean, not
cases.
not what they're doing necessarily, but like I don't know, some weird industry that you didn't expect would come to you. And maybe there's not. Maybe it's like it falls into those buckets and that's what you get. But anything that's come up.
Yeah,
throughout the.
so the automotive example I just gave actually would probably be the one that I just didn't even consider around sort of how they're using like the infotainment center, right? And so think all the bells and whistles that exist in like, selecting your music and plugging in your device to be able to control the map system and all those kind of things. I think is a use case that I just didn't anticipate and realize that there are all these logs that are just constantly kicked off as a result, and someone might want to take those logs and figure out how to do something smart and special with it.
Are there any industries that you think it's underserved and they should be using it right now? They're like, we haven't really gotten these type of customers, but you can see like a direct path for them to really benefit from what you do.
I think there's probably a really good use case with hedge funds, and we've had some
Hmm.
conversations, but think of the predictive analytics that go into sort of running regression models and trying to understand how the market has moved historically based on whether it's macroeconomic factors or signals that have occurred, and how do I take this data and process it really quickly to be able to make smarter decisions in predicting what might happen in the markets in the future. And so I think that's a really interesting use case that I would love to sort of dig in and explore more with some of the sort of larger to mid-size hedge funds. I think that's an interesting one.
Yeah, anyone moving large sums of money, it would be helpful. I'm sure like trading companies, banks, and those kind of things. There's a lot of data
Absolutely.
that's moving around.
Yeah, no, absolutely there is. There is.
What about from in the beginning of Voltron? Do you
Yeah,
remember when they first started? What did that look like? I mean, how are you even This is a very technical
yeah.
explanation. Well, who are some of those people early on that were using it that maybe it's not a fit anymore for Voltron? Maybe it is still.
Yeah, so I mean, we don't have a ton of customers that have sort of, we started the journey with 3, 4 years ago that aren't sort of, that have sort of, we've outgrown them or they're no longer. There's a similar level of applicability. Now, I should be really clear. I wasn't at Voltron Data at the beginnings. I've been at the company for about a year, and the company was founded in 2021. And so we did start our go-to-market early, really focused on, if you recall, I talked about the core IP, the query engine itself is closed, it's proprietary, it's ours, that we license that technology, but everything sort of around the ecosystem of that engine to make it really easy to embed that engine into existing data systems. A lot of our early customers, we focus on sort of driving adoption of those other technologies such that when we're ready to launch the core product, it's easier for our customers to work with us. And so a lot of the early customers were, hey, you should be using these open source technologies, Apache Arrow, IBIS, Substrate, et cetera, these technologies. And then the more adoption we get of those technologies when we release our product itself, then it becomes that much easier for the customer to work with us. And so early on, we focused on that a lot. And then about 6 months ago, really, we started really turning our attention more towards the query engine first as like SKU number one, and then the driving adoption of those other technologies in more of a services offering becomes SKU number two for us.
Craig, talk about your path for a second. I mean, you're in this, with Voltron Data. You started off an investment banking analyst. Did you ever think I'm going to be working with like
No,
SaaS companies someday?
no, 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 I did not. And yeah, I still to this day, I somehow don't realize how I got here. And it's so here is the path. You're right. So I was a finance major. I went to Hampton University. Big shout out to my home by the sea down in Virginia. And I went to Hampton University and I graduated in '02. And I took this job in investment banking because when you're a finance major, someone tells you that the creme de la creme of corporate finance jobs is investment banking. And I was fortunate enough to get one of those. And so I took it. And about a year and a half into that job, I said, yeah, there's got to be a better way because I love working and I've learned a ton, but I was working 100 hours a week, and I just knew that I wanted to do something different longer term. And I came across this company called Capital IQ, which was a financial services data company that was selling into investment banks. And so it was SaaS before SaaS really became a thing, and it was one of the dot coms that survived the sort of dot com crash in 2000 or so. And Cap IQ was looking for investment bankers who can come in and say, "Hey, built by us, for us," or sort of mentality, which is hire as many former bankers as possible, sell this really cool tech into bankers, and that sort of made my transition into technology. And who knew that company would go from less than 50 people or so when I started to a few hundred people before I left, and had grown to a couple hundred, 100 million in ARR at the time that I left. And so suddenly I went from this financial services guy to this financial technology guy. And I decided we got acquired by S&P or Standard and Poor's. And then I decided, okay, this is getting bigger, slower, because when you work for a bigger company, that's just naturally what happens. It's just the evolution of businesses. But I knew I wanted to do it all over again. And so there was one of the founders of a company called Seismic, which you mentioned, you made reference to in my bio earlier, who also used to work at Cap IQ. And he gave me a call and said, hey, we're looking to do this thing. And, we got this great company and we're headquartered in San Diego. And I was like, ooh, sunny San Diego. That's amazing. I can't wait to go live there. And then he said, no, 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 we actually want somebody in New York. And I was like, oh, okay, fine. I guess New York will have to do.
Where are you from
And
originally?
I'm from New Jersey. And so New York was
Okay.
kind of like going home in some ways, not quite the same, but
Yeah,
I
I'd be
spent the early
jumping
part
at
of my
San
career in New
Diego
York.
as well for the weather purpose. Yeah, exactly.
Yeah, I thought it would be interesting to live on the West Coast. I was living in London at the time, and then so the idea of going to San Diego was more interesting than going back, quote unquote, home to New York. But I got to Seismic, and it was again, hey, we've got this really cool problem, and we're solving, this sales enablement problem, and so I started working with sort of all customers. But as you might imagine, my background being in financial services, from investment banking, from Capital IQ as a financial data company, suddenly we started finding these niche solutions for seismic within financial services. And so we said, hey, we should really focus on this. And so we carved out about half the company and said, Craig, you're going to be the general manager. You're going to run all of the financial services verticals, so sales, marketing, customer success. You're going to make sure that we've got a story that's repeatable and we know how to tell that story, and we're just going to really focus a subset of the company on that. And so that really transitioned me into this like cross-functional leadership role where suddenly I'm not just, focused on sort of pre-sales or post-sales sort of consulting. I'm now focused on broad management and really focused on how do we sort of drive a go-to-market motion around a subset of customers, specifically within financial services. And then it just sort of evolved from there. And it was one GM job to another GM job to another GM job. And suddenly, I hate
And
the
seismic, really bad, really quickly. I mean, we're talking, there are over 1,000 staff here, right? I mean, this is a large company. I mean,
now
right?
now it is. When I started there, I think I was somewhere between employee number 20 and number
Wow.
25.
Holy
And so
cow.
now Seismic is probably, I don't know, 1,500 or so people. When I left, it was probably just over 1,000 or so people. And so I was there for 6.5 years of 100%, doubling every single year, both organically and inorganically as a result. And so it's a really fun growth story to tell.
Talk about the leadership, you growing as a leader there, obviously, starting at 20, and then you're in charge of this, large financial services department,
Yeah.
and how you grew as a leader.
So yeah, that's a really good one. I mean, there's a couple things. There were a couple people at Seismic, I think, that were really influential to me. The CEO is still a good friend and mentor of mine today, Doug Winter, and so I adapted a lot of my leadership style from him. The CTO, Mark Romano, I often joke with him, and I say like the reason I joined Seismic was because of Mark, and we did this interview, and I was just so blown away by his intelligence and smart, and I was like, if he's running the product direction, this thing is going to really go somewhere, and I think so. The two of them really had a lot of influence over me as a leader and becoming who I am. And they're just lessons that you pick up along the way as you think about what the company needs from 5 million to 20 million, or 20 million to 50 million, and 50 million to 100 million. And at each stage, the company needs something a little bit different, and you just have to adapt yourself. And I've become pretty good at doing that. Um, I'll give one other little example or tell a story which I think has really served me well. But I had a leader just before I joined Seismic. Her name was Amy Katamatsu, and one of the things she said to me right when she left Capital IQ to go to her next gig was, she's like, Craig, your biggest strength, and one of your biggest strengths is people. And she's like, people like you and they like to work with you and they like to work for you, and you've done a really good job at just sort of being able to get buy-in and being able to influence without being sort of forceful or heavy-handed. And she's like, if you can figure out how to just take that people skill and leverage it, you're going to have this exceptional career. And so I really started to think about that advice. And I don't know if I intentionally do this or not, to be honest, but you know, I, it just made me really appreciate the importance of hiring great talent, letting those really talented people, giving them the space to do the things that they do well, not having a big ego about it, looking for people that are smarter than you, and just like building relationships and bonds for people to work really well together. And I think that has served me well throughout my career.
I thought there was going to be a but after that, where she was going to
No,
say,
but
but okay. Like, you're really good with people, but I was waiting for
maybe
that.
there was. I tend to remember the positives. I don't. Maybe there was some negatives in that final interview or final sort of exit interview right before she left. But I remember the positives.
Yeah, no, I love it. And then what about with Lumar?
With Lumar, it was a different situation. It was, the company had historically been sort of a product-led growth, and they were moving to an enterprise-led growth motion. And so they wanted to bring in a leader who could really help the company go through that transition. I'd say the big lessons I learned there were, it was the first time I was at an entity that, we were doing well. Growth had slowed a little bit, and so I got hired in to really sort of kickstart growth. But it coming from Seismic, where we were growing 100% every single year, we were just rolling, and you get to Lumar, and it's a more crowded space with more competitors. We were, a smaller player, and there was in some ways, a misalignment of, as we moved from this product-led motion to an enterprise-led motion, we needed to sort of match the talent to be that of an enterprise-led motion, and so it required us to make some additional hires and, move on, unfortunately, from some people as well. But that was the lesson there. It was the importance of aligning the talent with with the task that you have at hand, which maybe feels like a blatantly obvious thing, but it's sometimes hard when you come into a company and there are people who have been there for a long time, and, they're really nice and great people, but maybe they're not the right fit for the role. And so my big lesson or takeaway was, you can't wait too long. If your instinct says someone's not right for the role, you unfortunately need to make the decision for the company, but also probably for them. Like when someone's not right in a role, they know it, they feel it, they're probably unhappy, and it's best for everyone to just make a decision as quickly as possible.
What's that conversation look like? Because that's a tough conversation, especially maybe if you've known them for 20 years and like, but you're coming in and you're like, we need to shake things up and improve. And obviously you're a people person, so I'm sure you game report quickly, but what does that conversation look like? How do you initiate it and then have that conversation knowing in the back of your mind
Yeah.
it's going to help the company and ultimately help the person, but no one likes change. I mean, even if
No.
they want the change, no one likes it. So what does the conversation look like in that situation?
Yeah. Having having tough conversation, you're right. It is difficult. And I tend to usually open with an acknowledgement that it's going to be a tough conversation just to sort of set that framing first. And I usually will try to get to the point first because I don't think it's good to just have this anxiety building and building for 30 minutes over time. It's like, look, I'm just going to get to the conclusion and then we can go back and talk about how we got to that conclusion. And so if it's delivering news, like not the right fit for the right role, I usually open with that. And then I talk about the logic of what I see in terms of their skill set and their qualities and what we need specifically for the role and try to be as logical and just point out the mismatch of the skills with what we need at this moment. And it's typically, and oftentimes it's not a reflection on them as being an underperformer in any given way, but it's more so that, hey, I think this kind of role is probably a better fit for what you want to do long term and better fit for your skill set. And if there's another space and place within this company where we can put you in that, I'm open to it. And if not, then I'm also open to supporting and endorsing you to go find something else that's probably and perhaps a better fit for you. And I'm happy to be a recommendation to talk about all the skills you do have that align with this other role that makes, I think, more sense for you.
Do you usually come in with the conversation thinking of, okay, there's another role or this is not going to work out? Or are you kind of exploring it with them?
It, the answer is always it depends. There have been situations where it's been both. There are times where
Yeah.
I've known conclusively that someone is not right for a given role, and so that decision has been made coming into the conversation. But in all those cases, I have another really good friend of mine. She's super experienced in HR. Her name is Nicole McGuire. We worked together really closely at Seismic, and one of the things that she always taught me was, if someone is, if you need to move on from an employee and they are surprised about it, then that's your fault as a manager. Like no one should be surprised that they're not a good fit or that things aren't working well because you should have been giving them feedback along the way. You should have been sort of like, helping them and coaching them and guiding them and and all those things should have been happening. And so they should have known that something wasn't 100% right. And so it shouldn't be a surprise. But then there have been other situations where it's like, and I would view those more as like feedback conversations or even quarterly or annual reviews where it's like, hey, we're going to go through more formally, like what you're doing, what you're not doing, where I think you can do better. And in some of those situations, we can kind of really work through how do we get them to a good place where they can be more productive.
Yeah. So I guess I visualize the approach as kind of like a bit like ripping a Band-Aid, like letting them know this is going to hurt and just go like just rip it off and then maybe go back and do the
Go back.
explaining. So there's no anxiety around
That's right.
doing it slow. Actually, there's Dan Ariely in Predictably Irrational talks about, I think it was his book that talks about, just ripping a band, like he was a burn victim and had when they took off the bandages really slowly, the nurse thought they were doing something good by him to like let him adjust to the pain, but he's like, it was way better when they would just rip it off and not like make him toil slowly, anguish over
Yeah.
taking these off.
Yeah.
I'd love to
Yeah.
hear, Craig, some of your favorite resources. They could be books, they could be podcasts, they could be, software that you like. For some reason, this journey reminds me. I had Richard Wilson on the podcast who runs billionaires.com and familyoffices.com, and he recommended a bunch of these books written by billionaires. And his argument was like, hey, Jeremy, do you want to read a book by someone who's never made money before or someone who's accumulated billions of dollars? I'm like, okay, that's a good point. So he's got a list on his site, and one of them was What It Takes by Steven Schwartzman, who co-founded Blackstone. And for some reason, like this winding journey, like when I listen to it, somewhat reminds me of that book, What It Takes, because he was kind of like all over the place with different things, all
Yeah.
finance and things like that. But I'd love to hear some of your favorite resources that you've,
Yeah.
appreciate
Yeah.
throughout your journey.
Yeah, so I say a couple podcasts I listen to quite a lot. How I Built This with Guy Raz is one of my favorites. Masters of Scale with Reid Hoffman is another one that I listen to a lot. And they're all stories about like how do you grow businesses and really practical success stories. And then I am like an avid reader. And oftentimes I read a lot of fiction, but when I do read nonfiction stuff. It's business books, and some of my favorites are Hard Thing About Hard Things is one of my favorites. Starts with the Why. All of the like big fan of Patrick Lencioni, and so he's got like Five Dysfunctions of a Team. Is one of the other ones. Oh my God, the book about meetings is driving me nuts. I can't remember the name of it right now, but there's a number like that. Brene Brown, Dare to Lead, I think is an interesting one. It also talks about leading with vulnerability and sort of the human element of being a leader. Are some of the ones that I would recommend, or the authors that I would recommend.
Yeah, I think the Patrick Lencioni one, I remember, if that's one you're referring to, I think it's Death by Meeting or something like
That's
that.
it.
Yeah,
Thank you. Yes, that's the one. That's the one. Thank
He's
you.
got a lot of
Yeah.
good ones, though.
Yeah.
No, I appreciate that.
Yeah.
No, first of all, Craig, thank you. Thanks for sharing your journey, your knowledge, and your lessons. It's been super valuable. I want to encourage everyone to check out voltrondata.com to learn more and more episodes of the podcast. And we'll see everyone next time. And Craig, thanks so much.
No, thanks for having me. I appreciate your time.
What I got, you can't buy. It resides between my eyes. Walked through the fire, came out better on the other side. See, life's like a beach if you find the sailing right now. I feel like 100 grand.